Algebraic and transcendental function. There are two types of functions. First one algebraic function and the next one transcendental function. An algebraic function is informally a function that satisfies a polynomial equation. A function which is not algebraic is called a transcendental function. The values of x which satisfies the equation f of x equal to 0 are called roots of f of x. If f of x is quadratic, cubic or biquadratic expression, then algebraic formulae are available for getting the solution. If f of x is a higher degree polynomial or transcendental function, then algebraic methods are not available. Consider a continuous function. Numbers a less than b such that f of a and f of b have opposite signs. Let f of a be negative and f of b be positive for closed interval a and b. Then there exists at least one point, that is root, say x lies between a and b such that f of x equal to 0. Now according to bijection method, biject the interval closed interval a and b, x1 equal to a1 plus a plus b equal divided by 2. x1 lies between a and b. If f of x1 equal to 0, then x1 be the root of the given equation. Otherwise, the root lies between x1 and b. If f of x1 less than 0, or the root lies between a and x1. If f of x1 greater than 0, then again biject this interval to get next point x2. Repeat about the procedure to generate x1, x2, etc. till the root up to desired accuracy is obtained. Bijection method characteristics. This method always slowly converges to a root. It gives only one root at a time on the selection of small interval near the root. In case of the multiple roots of an equation, other initial interval can be chosen. Smallest interval must be selected to obtain immediate convergence to the root. Example for bijection method. Find real root of x cube minus x minus 1 equal to 0. Correct up to 3 decimal places using bijection method. Now we see the solution. Let f of x equal to x cube minus x minus 1 equal to 0. Next we get to find out f of 0 and f of 1, and finally we have to find out f of 2. From this we get positive and negative root. Since f of x is continuous function, there must be a root lying in the interval 1 and 2. Now we see the midpoint c equal to 1 plus 2 divided by 2. Finally we get the answer, that is c value 1.5. Next we see the next example. Find the real root of x cube minus l nx minus 12 equal to 0. Correct up to 3 decimal places using bijection method. Now we see the graphical derivation of the method. Consider the portion of the graph y equal to f of x which crosses x-axis at r corresponding to the equation f of x equal to 0. Let b be the point on the curve corresponding to the initial guess x0 at capital A. Next we take the tangent at b. Next we see AB equal to f of x0, AC equal to x0 minus x1, ACB equal to alpha, tan alpha equal to AB divided by AC, f dash of x0 equal to f of x0 divided by x0 minus x1. Next x0 minus x1 equal to f of x0 divided by f dash of x0. From this we get x0, and from this we get x1. x1 equal to x0 minus f of x0 divided by f dash of x0. In general, xn plus 1 equal to xn minus f of xn divided by f dash of xn. In NR method, two functions f1 and f dash are required to be evaluated per step. Also required to evaluate derivative of f, and sometimes it is very complicated to evaluate f dash. Next, from this we get m dash of xn. After that, xn plus 1 equal to xn minus f of xn divided by f of xn minus 1 minus f of xn divided by xn minus 1 minus xn. General features. The second method is open method and may not converge. It requires fewer function evaluations. It's some problem. The second method will work when Newton's method does not, and vice versa. This method is usually a bit slower than Newton's method. It is more rapidly converged than the bijection method. This method does not require use of the derivative of the function. This method requires only one function evaluation per iteration. Thank you.